Next, we're getting into polynomials, and we're going to learn how to combine like terms when you're adding polynomials. So first, let's see what a polynomial is. In order to define a polynomial, it's really important to know what a monomial is. So think about all of these prefixes that you hopefully know already. Mono means one. So a monomial is a term or a single term that contains only multiplication of numbers and variables with non-negative, meaning positive or zero exponents. So if you take a look, an example of a monomial is -8 x cubed y to the 7th z. Notice there's all multiplication. We're not adding or subtracting anything. When you get into a binomial, that's when you're adding or subtracting two monomials, bi meaning two. Trinomial would be adding or subtracting three monomials. Tri means three. And then a polynomial just means many. And the most basic definition of the polynomial is addition or subtraction of more than two monomials. So technically a trinomial would constitute a polynomial. And finally, we're going to take a look at what I mentioned was like terms. So like terms are monomials with the same variable to the same power. So 3x squared and -8x are not like terms because they didn't have the same power. But if they both have a power of 2, or they both have a power of 1, or they both have a power of 16, then they would be like terms. What we're going to learn today is how to combine polynomials, which essentially boils down to combining like terms. And our essential question, this whole unit has been a simplifying unit. So today we're thinking about why do we even need our expressions simplified? Starting off with adding polynomials, this is much easier than subtracting, just like regular numbers. Adding is easier than subtracting with regular numbers. Adding is easier than subtracting with polynomials as well. So we're simply looking for our like terms. So I have a -x cubed and a positive 5x cubed. I want to start with the term with the highest power because then our answer will end up in what's called standard form if you have the highest power first, and it goes down from there. So remember, when you have -x cubed, it's really like you're multiplying by a -1. So -1 plus 5 is 4x cubed. Remember, when we multiply powers, we add the exponents. So if we're adding powers, our rules need to be different than our multiplying rule. When you add like terms, the variable piece stays the same, and the coefficients, remember the number that you multiply by the variable, the coefficients are what you combine. Next, I notice 15x plus 10x, so that gives me a total of 25x's. And 3 minus 5 is -2. We'll take a look at one more. This time we're adding a trinomial and a binomial. So I'm noticing my 3a squared term is lonely. It doesn't have any like terms, so I don't have anything to add that with. A plus 2a gives me a total of 3a's. Remember, this first a here, it's like there's an imaginary 1. When you multiply by 1, it doesn't change anything. So in simplest form, we remove the 1. But when we're combining like terms, it's helpful to think about that 1 being there. Positive 5 minus 5 is 0. And again, adding 0 isn't in simplest form, so we're done with our expression on this one. Subtracting can be just as easy as adding if you follow one rule, and that's the rule that I have in the right-hand column over there. Distribute the negative sign. Remember, this is like a -1. We're multiplying by -1. So if we add the opposite on everything in that second set of parentheses, changing the sign on everything, then we have adding, and it's just as easy as what we just saw. So we've got -4w cubed plus 2w cubed gives me a total of 6w cubed. Again, don't change that exponent. 2w minus w, because we changed the sign, is a positive 1w, but when we simplify our answer, we don't write the 1, and -3 plus -7 is a total of -10. We'll take a look at that one more time as well. Again, first step is add the opposite. Our subtracting rule when we're adding numbers is add the opposite. So our subtracting rule when we're subtracting polynomials is add the opposite as well. So we're going to distribute that negative sign through and change the sign on everything in that second set of parentheses, and then we can add. Our 8c cubed has no like terms. There are no other terms in either polynomial that have a power of 3. So we've got 8c cubed plus 2c squared minus 9c squared. For some of you, adding numbers with negatives may be a little bit challenging. One thing to think about is money. If you have $2 and you spend $9, you are $7 in debt, which means you owe $7. So we use a negative sign to show that we owe some money. We have negative 6c plus 5c. If we're $6 in debt and we pay off $5, we're still $1 in debt. Again, when our coefficient is 1, we don't show it. And then we have our plus 11 on the end here with no like terms. Finally, our error analysis. So take a look at what I'm doing when I'm combining these polynomials and find my mistake. All right, so we have subtraction, so I'm going to start by subtracting my 9g squared and my 4g squared. And 9g squared minus 4g squared gives me 5g squareds. And then I have plus 3g minus 7g, which is a negative 4g. So find my mistake on this one. Make sure you're taking a close look at how I was subtracting those polynomials.